All right, so did you guys draw a sketch of this first one? What kind of triangle are you drawing?
Equilateral.
Okay, that's pretty simple, right? Just rough. All sides are congruent, and they're all what? 20. And there's 10th. What's a height? What's another word for height in a triangle? For what? Altitude, right? And how do you draw that? Perpendicular to the base, right? Hey, does this look familiar, like where one of our special right triangles came from? Does it? So before I drew that height in there, what was the measure of each angle in that equilateral triangle?
20.
Angle.
Oh, angle 60.
60 for each of them, right? But then what happened up here?
You put that in half, so it would be 30.
Hey, remember that's where the 30, 60, 90 came from. So what do they want to know? What the height is, right? Does that look familiar? Like what's up on the wall there? What's the length of this segment here? Oh, okay. That segment happens to be what part of that 30, 60, 90?
Base.
Sure. Of the 30, 60, 90. Hypotenuse, long leg, short leg.
So
That's the short leg. You get the long leg. Go ahead. It says to the nearest what? So you'll need what? A calculator for this one. You know what you're all waiting for. Do that
just
now.
trying to make sure we go like one.
Okay. Let's make sure. You have what you need, right? The short leg, that's what you need. Should be pretty simple.
We're add too much.
Well, I don't know, it's up there. It's right in front of you on the wall.
This is 2x though.
Yeah, that's the hypotenuse.
I'm just gonna guess from
What part is that? What part of the 30, 60, 90 is that altitude? Everybody? It's a long leg. You got the short leg. Ah. We call it X. What does it equal? X.
17.3.
How'd you get 17.3?
Like 10 times the square root of 3.
Oh yeah, short leg times the square root of 3. But they wanted it how? To the nearest tenth, right? An approximation. What'd you get?
17.3.
17.3. Okay? And number 2 is a little tricky. You're going to want to sketch that. And you're going to want to draw or inscribe your square. It doesn't have to be perfect, right? If you inscribe your square a certain way, this will work out for you as one of our special right triangles. Okay, so take a minute, see if you can sketch that out. I'll help you with the circle. Okay? What do they tell us about that circle? Oh, might as well put that in there. So that's be the center, right? So we'll call this 7. And what do we need to put in that circle? Square. Any thoughts on how to sketch that square in there so that it becomes maybe one of our special right triangles? Huh?
So a diagonal line from one edge to the other.
Okay, we need to think about the diagonal of it, right? So, like specifically, where would the square's diagonal be to be most helpful?
Top left, bottom right.
Huh?
Top left, the bottom right.
Well, I'm not sure what that means.
So we really do the square.
Well, somebody's going to figure this out. Take special right triangle. Also, by the way, if we're going to have a square in there, we're going to have a couple of triangles, right? We draw a diagonal. And you know what kind of triangle happens in a circle? when it's got a certain part of it as its hypotenuse. Well, how should we draw it though? She's just pointing. Come on. A line down the middle?
Maybe you still don't got a square yet.
I know, that's why I'm asking you. Right, clearly. I want to draw this square so that I have one of my special right triangles to work with. And a measurement there that's given. Can I ask you a question? Go back in your notes and flip back and see where did our 45, 45, 90 triangle come from? How was it derived? Take a minute and look back. Circle, given that our circle here has a diameter of 7, thinking about the diagonal of the square from which our 45, 45, 90 comes from, how should we sketch the square in there? Perhaps there's a specific way to place the square's diagonal in this particular circle that we've all drawn.
Does it need to be exact? It's multiple choice.
We don't do multiple choice in here. Multiple choice in math is invalid. Because a reminder, every single one of these could be presented as a written problem too. That's going to prepare you for it. Come on. It's not like one way to do this. No.
Is the diagonal?
Right. So the diagonal of the square is the diameter I drew in here. I'm not sure why that took so long. Whoops.
Good team. It wasn't on there.
There's lots of things we haven't learned that you have to take your brain to the next level and think about what we did learn and apply it to something else. So now what kind of triangle do we have here?
I was right. 36, 90?
You sure about that?
No.
It was a square. It's a 45, 45, 90.
I'm on top of the game.
Yeah, and I'm telling you to stop. And that's the thing.
Hey, at least I'm trying.
Right?
So now what do they want? What is it they're asking for?
Sideline.
Okay. So now you know how to figure that out because now we have one of our triangles, right? What's that side length going to be? That 7 is what part of the 45, 45, 90? And I know you know by now how to go from a hypotenuse to one of the legs in the 45, 45, 90 because it's right up there on the wall. What do you do? By? Oh. Now, can I ask you a question? When you do that, given the way they asked this and the form they want it, do you need to put that in simplest radical form? So that side length should be what?
I need a clue what I'm using to get the.
What should I write for this side length? You just told me. Huh? 7 divided by square root of 2. How do they want the answer? So do I need to bother rationalizing, multiplying by the square root of 2 of the square root of 2 here for this particular one? What could I do right now? Yeah. What do you got? 4.9. And yes, we did learn this because it's a 45, 45, 90. It's just, you got to be able to apply this to things you haven't quite seen before, right? So choice 2. Okay, I think this is one more. Is this one we've seen before
I don't know.
in an earlier section?
It's on our review sheet.
That's true. I said before, though.
Yeah,
In the previous section, chapter.
I remember
Well-
seeing something similar. to
Okay,
it.
read this over. Label things in there.
Wait a minute.
It's a line, man. The poster and the frame. So really, that's 2 things, isn't it? Okay. So how do you, can't answer that. How do you find the area of a square? Oh.
Like template.
But what's in a square? What do you know about the base and height?
They're all the same.
They're the same. So all you have to do is get 1 and then do what to it? Multiply it by itself. In other words, what? Square it. Hey, it's a square. That's it, right? You get the thing. Okay. Square, where the term comes from. So we just need to find some dimensions, don't we? Okay, find them. What kind of triangle do we have here?
45, 45, 90.
We sure do. So that's a 45, 45, and there's my 90. What part of that 45, 45, 90 have they given us? Okay, so you need to find one of those legs, don't you? Maybe I'll put an X here. And how do they want their answer, by the way?
Nearest tenth of a square centimeter.
Okay, now here's the thing. Whatever decimal that they ask you to go out to, while you're working with the problem, do you know how many decimal places to keep your work out to? Like if they want to the nearest tenth, how far should you be working out?
2.
3 or 4, right? Right, always do 2 or 3 past what they want. If they want 1 decimal, right? You should be out like 3, maybe 4. Until the very end. Okay, don't round until the very end. But there's a little twist to this one, right? So you guys can find this X, can't you? Because, you know, it's up there on the wall, right? What do? What do you do to find this side length? Divide by? Oh, okay, yeah. Go ahead and do that. So it's 58 divided by the square root of 2. Might as well get a decimal approximation here. What will it be?
41.01.
41.012.
Yeah.
You guys agree with that? So if we just multiply that by itself, will that be the area of the whole thing? It won't, will it? What do we have to also include?
The frame.
The frame. So what do we do with this 41.012?
I always say add 4 to that one.
Add 4. Well, okay, the frame is 4, right? So that means that that's 4, isn't it? Okay, so we just add 4 to it? Because we need this whole length, don't we? We just add 4 to this? Huh? The frame goes all the way around, doesn't it?
Yeah.
So what do we actually add to this to get the whole length? The frame goes all the way around.
16.
8! Isn't this 4 as well? So if this is 41.012, what do we have to add to it? Huh? 8! What do you got? You said what? How about 49? We're adding 8. Right? So what's the area? That is not the area. That's the side length of the square.
We gotta multiply that by itself.
Okay, you mean do this? Is that what you mean? All right, do it. What is the area of that picture, the poster and the frame together? That's not 1, 2, is it? Oh, it is 1, 2. I want to know. Yeah, that's right. What's the area? In here.
2,402.176.
2,000, say it again?
2,402.176.
See that?
0.6.
0.2, rounded correctly. What are the units?
Centimeters squared.
Centimeters squared is this area. All right? Good idea? It's a tricky one. You had to add the frame on both sides of that to get the whole side length. All right, so it was just a special right triangle again, that's all it was. Same thing. That was the last one, right? Okay.